Hello, ladies and gentlemen. I hope you are fine wherever you are. I am the ACCA tutor, Mr. Jerry Chimukulu, and in this video, I would like to take you through some computations related to two common uh, topics, which are a rich example for the ACCA Pm examination. All right, and these are the learning curve theory and uh, time series and regression. So uh, those are the two topics which we'll be covering in this particular video, and I just hope that you're going to enjoy the video, but at the same time benefiting from whatever process we'll be tackling. Okay, so without wasting much of your time, ladies and gentlemen, let us go straight to the business of the day. Now, at the bottom of the learning curve theory, uh, we should know that as the cumulative output doubles, the cumulative average time per unit falls to a given percentage of the previous average time per unit. So basically, the assumption underlying the learning curve theory is that as manual labor is exposed to similar processes, over time, their efficiency is going to improve. Okay, but we just have to know that this improvement in efficiency is not always going to occur. Okay, there's a stage when the improvement is going to be zero. Okay, where the learning curve has reached its maximum point. All right, so at that stage, we are not going to experience any reduction in terms of production time. All right, but that one is part of the discussion. All right, there are certain conditions which have to exist. For example, the workforce should be motivated. The production processes should be highly manual for the learning curve to be sustained. Okay, so let us get through this particular example to see how we can elaborate the theory better. Okay, all right, this computer of mine sometimes sticks. Okay, the time taken to produce the first unit is 100 hours. There is a learning rate of 75%. How long will it take to produce an additional 7 units? Here I've been reminded of some points here. Um, when I was having some discussion with some of my students, they were saying, this rate, what do they tell? Let's say the rate is 80%, or the rate is 75% or 60%. What does this rate entail, or what do they mean? Okay, we are simply saying if the rate is higher, then more training is required. It means that the production efficiency is poor. But when the learning rate is low, then it simply means that the efficiency has improved. Okay, let me try to elaborate this point with some figures. We are going to do that example, to not worry, but I think we need to just have some solid background. Okay, let me try to find this. All right, just come. All right, pen, where are you? Okay, all right, let us say the time taken to produce 1 unit. Okay, 1 unit. Okay, the average time and total time. All right, let's say the average time to produce 1 unit was 100 hours. Okay, so obviously the total time becomes 100 hours. But when the production doubles, the time taken, the average time for the 2 units was, the average time per unit to produce those 2 units was 80 hours. All right, so total, this becomes 150 hours. Okay, then when production doubles again, the time taken, uh, in this case, is, the production head actually was taking about 64 hours per unit. Okay, and the average becomes 16, 4 by 6, 24, so that's 256 hours. All right, and when the work doubles again, this time it becomes something like 51, right? Something like 51 hours, right? And when it becomes 408 total. Okay, now as you can see here, it simply means that there has been some 80%, okay, some 80% uh, learning rate, okay, and if we subject the other units produced to the 80% learning curve, it simply means that it's 80% multiplied by 80, okay, and we get some 64, right? So you're still using the 80% rate, all right, and here the 80% multiplied by 64, it might be varied there. Let me just try to verify um, the actual figure we were supposed to have there. Check time again. Anyway, calculate of mine. Okay, coming up. Okay, so we are saying that's 80%. So it's almost about 51.2. All right, so we're almost there, which is fine. So you can also see that there was an 80% learning rate. Okay, but now let us use the 90%, okay, 90% learning rate, and you will see that the higher the rate, the more the time and the less the efficiency. So let us say the first unit was also took 100 hours, but the average time for the um, for 2 units, okay, or for seconds, uh, the succeeding units, okay, the average time taken to produce 2 units thereafter was 90, okay, per unit, 90 hours per unit, because that's the um, the average hour taken, okay, at a 90% learning rate, okay, and you can also see here that hours become 81, all right, average, because we are simply multiplying by 90% on the previous result. And here you can also see that it becomes some 72 point something, all right, 72 point, let's say 9 hours. All right, so in total you could see that fine, the first one is 100 hours, but the second one now is taking 180 hours, and this one is taking about 432, all right, hours. So you can see, and so on and so on. You can see that the higher the rate, all right, the higher the rate, the lower the efficiency, all right, because it is taking time, more time to produce units. So the lower the rate, the better. The lower the learning rate, the better. The lower the learning rate, the better. That's the advice, my student. Okay, so let us get back to our example here and see if we can come up with something. In this case, the learning rate is 75%. All right, so we can just do the same thing. All right, let me try to get a more clearer pen. Okay, so we are simply saying the production of one unit took 100 hours. Okay, 100 hours. Let us call this one the average and the total here. All right, the production of 2 units on average took 75 hours, because we are multiplying it by the 75%, and okay, the first one was 100 hours total. Then the second one here was the 2 units in total took 150 hours. That is 2 multiplied by 75. What about the when these 2 units were doubled to become 4? Then it means that the time per unit, that's the average time per unit, should be 75 multiplied by 75%. And let us see what do we get. 0.75 multiplied by 75, we should get 56.25 hours. And when we multiply that to get the total, how much do we get? That is say multiply by 4. That's 225. Okay, 225 hours. All right. What about when it becomes 8? Obviously, if we multiply by the 56.25 by 75%, 56.25 multiplied by 75, we get the average time per unit of 4219.19 hours. Okay, and this should give us, multiply by 8. That should give us 33.7.5 hours. Okay, so the question is saying, how long will it take to produce an additional 7 units after producing the first one? The first one, we realized that it took 100 hours. All right, and the production for the 8 took 300, and for 8 items in total took 337.5. Okay, what this simply means is that in pictorial view, this simply means that we are having something like this. Okay, graphically, this is our graph, ladies and gentlemen. Okay, the y-axis is the time. Okay, this is the time, and this is the x output. Okay, the output. All right, so the first unit here, unit number 1, took 100 hours. Okay, took 100 hours. But okay, so the first item was here, and then the eighth unit, eight units took about 375, 337.5 hours. So we were somewhere here. Okay, the learning curve, ladies and gentlemen, is not linear. It is an exponential function. So it represents some. The graph is like this. Don't mind my, my poor drawing. It is something like this. Okay, that's a linear function. An exponential function where we have the graph is not purely linear. All right, it's curvical. It's some convex. Okay, so there is a formula we will be using to estimate this, which is normally y is equal to ax to the power b. Okay, that's the equation. It's an exponential function. All right, it's an exponential function. All right, so so far what we know is that 1 unit, okay, 1 unit took 100 hours, and then 8 units took 337.5 hours. That's what we know. All right, but we are required to determine the time that 7 additional units would take. All right, so there was actually need to determine how many hours would be taken by 8 units, which we did, and we discovered that they were, we need to have 337.5 hours on budget. So obviously, the time that will be taken to produce 7 additional units would be the difference. Okay, would be the difference between the time taken to produce 8 units and the time taken to produce 1 unit. All right, so obviously our answer is going to be okay, time for 8 units, sorry, 7 units, 7 units should be the time for the 8 units minus the time for 1 unit. So that's 3,375 hours minus 100 hours, and we should get 237.5 hours. That's the time for the 7 units, ladies and gentlemen. And I hope you have benefited from this computation. However, our forthcoming examination, we are not going to be expected to write anything like this. We would be using the provided spreadsheet. So in my next computation, I'm going to use the spreadsheet so that we are home and dry when it comes to the use of spreadsheet. Okay, ladies and gentlemen, so let us try to attempt a past exam question using a spreadsheet where possible. All right, please stay tuned as I try to pick and to locate this question. Okay, let me try to find the question. Yes, I have found the question. Okay. Question number 1 is saying a company predicted that the learning rate for production of a new product would be 80%. The actual learning rate was 75%. The following possible reasons were stated for this. So in this case, we are given, it's a theoretical question that is testing our understanding of the learning curve theory. And I've indicated that when the learning rate is higher, it simply means that the efficiency is low, but when the learning rate is low, then the efficiency is higher. We are taking less time to do things. We are taking less time to get our skills. All right. So the learning time, the time required for training is shorter. All right. If the learning rate is low, okay. But if the learning rate is high, then it simply means that we are taking more time on training. Or we are requiring more time on training, something like that. All right. So you need to reason along those lines so that you're not going to shoot yourself on the foot. Okay. So what could be the possible reason? Okay, because according to our budget, we were budgeting to have a learning rate of 80%. However, on the ground, we discovered that the learning rate is now 75%. What could be the reason behind this difference? Number 1, the number of new employees recruited was lower than expected. Okay, if we have few employees recruited, it simply means that we are likely to be more efficient because we are using highly skilled, experienced personnel. Therefore, we are likely to be more efficient. The other reason that could be put across is that fewer employees are easily trainable. Okay, it is going to be much easier to train a few or a small bunch of employees than the whole wagon of employees, which might actually retard the training process. Okay, so number 1 is a suspect. Number 1 is a suspect correct answer. Okay, you can just at least put that one into your pocket. What about number 2? Unexpected problems were encountered with production. Unexpected problems were encountered with production. Do you think that one is a reason why we are having a lower learning rate? Obviously, that's not a reason, because if we had encountered problems during production, then it simply means that our learning rate was going to be higher. We're going to have a learning rate higher, because I told you that if the learning rate is higher, it simply means that our efficiency is low. So number 2 is out, and by using the principles of elimination, you can see that A is out because it includes number 2. Okay, sorry, let me just try to locate a pair. My computer sometimes worrisome. Okay, very slow. I'm sorry, I will improve. Okay, so number 2, A is out because it includes number 2, which we said this one is wrong. So obviously this one is wrong. Okay, but obviously D is wrong because we said number 1 is right. So you can see, actually, by using the principles of elimination, you can easily answer these questions. So we are left with C, all right, which is 1 only. But let us look at item 3 and see why we can be right or wrong. Unexpected changes to health and safety laws meant that the company had to increase the number of breaks during production for employees. So if there was an increase of breaks simply means that we are not doing anything. Okay, we are not doing anything to production. We are retarding the production process. Obviously, we were going to expect a higher learning curve, a higher, learning rate. So, but we ended up having a lower learning rate, which means that we were efficient. So therefore, 3 is false. It's not true. So you can see that item 1 was the correct answer there. So this is our answer. C is our answer. All right, let's move on to part 2. Question 2, and see if we can make sense out of it. Okay, question 2. TechWorld is a company which manufactures mobile phone handsets. From the past experiences, TechWorld has realized that whenever a new design engineer is employed, there is a learning curve with a 75% learning rate, which exists for the first 15 jobs. A new design engineer has just completed his first job in 5 hours. Note, at the learning curve of 75%, the learning factor B is equal to negative 0.415. Okay, and this B which they are talking about is in the equation y is equal to ax to the power b. This is the B we are talking about. Okay, and we are told that the B is negative 0.415. Oh, if we were not given this factor, okay, we were going also to determine that, okay, by using the formula B is equal to LR log LR over log 2. Okay, and in this case log 75 over log 75 over log 2, 0.75, log 0.75, because 75% is 0.75 over log 2. All right, and you were going to get the same, which is negative 0.415. Sorry, let me just try to adjust my seat. Okay. All right, we are done. But anyway, I promise that we should do this in Excel. So I wonder what what I am doing here on this paper. All right, because in the exam we are likely to meet spreadsheets, so it is better we just try to learn using them. All right, so we are going to say let us type in learning rate. Okay, learning rate, or you can simply say LR, because examiners know that LR is for learning rate. All right, so the learning rate is 0.75. Okay, and all right, and learning index. Learning index is given by learning index or learning factor is given by, all right, log okay, 0.75 divided by log 6. Okay, you have seen that our log, the learning index or learning factor has been determined. sometimes the examiner do not give you and you must not be found wanting. You just have to know how to compute these formulas. All right, lucky enough, in the exam you'll be given, all right, in the exam you're going to be given the formula for the learning factor, you're going to be given everything. Okay, this equation y is equal to x plus b, it is going to be given again in the exam, so do not worry. Okay, you may also say, can we just bring this to the number of decimal places required, that is 3, so we can simply do that, a bit of formatting. Okay, super. All right, we have done that. That's our negative there. All right, but we're not going to get a mark because the examiner has given us that factor, so don't expect any mark from doing that. You'll be wasting your time. In the exam, you just have to fly. You need to learn to fly. Okay, now let's get back to the business. All right, let us try to originate figures. Okay, a new designer engineer has just completed his first job in 5 hours. All right. Okay, so we need to take this equation. Okay, we need to take this equation, but like I said, we are given these equations in the exam. Okay, so let us try to take this equation to a spreadsheet because it is going to assist us. So we know that y is equal to, all right, let me just say average time per unit, okay, is given by y is equal to ax to the power b. Okay, use that sign to represent the power. All right, so once you do that, you then have to say, all right, we know that a stands for the average time taken to produce 1 unit. I mean the first unit. Okay, average time taken to produce the first unit. Okay, and then the x, that's the units we want to determine. All right, the units we want to determine, and then the b is the learning index or learning factor. Okay, which units shall we determine? Okay, remember the question is saying how long would it take the design engineer to complete the skissed job. Okay, the skissed job. So in this case, we need to determine the total time for the skissed job and total time for the 50 job, and we get the difference because when the question is saying the time to complete the skissed job, so it simply means the time that is going to be taken from job number 5 to job number 6. So that's the time which we need. All right, graphically it's like this. Let me try to let me see if I have enough space here. All right, and let me try to erase some of these so that I illustrate this point graphically. Okay, graphically we are simply saying, ladies and gentlemen, we have our graph. Don't mind my poor drawing. We have this graph, ladies and gentlemen. All right, this is our time, this is our output. Okay, what we need is, all right, we know job number 1 took how many hours? 5 hours. Okay, we are told job number 1 took 5 hours. Time is in hours. All right. So this one we know took 1 hour. I mean 5 hours. All right, but we need to know job number 5. How many hours does it take? Okay, we need to determine that for this particular job because it's actually relevant to us, and we also need the time for job number 6. Okay, job number 6 should be somewhere here. Okay, and the time. All right, so we need to determine the difference. This point, that's what we need. Okay, that's what we need. All right, but this time here for the first job is also relevant. Okay, the time for the first job is relevant to our computation. All right, as you will see, the time for the first job is relevant to our computation. Okay, so this one is x6 and this one is x5. So the difference between x6 and x5 should be our answer. Okay, so going back to our spreadsheet, let us determine can as well work on this side so that average time for 6 jobs. Average time for 6 jobs using the formula is equal to time for the first job, which was 5, multiplied by 6 jobs. Okay, multiplied by 6. All right. Multiplied by 6. We can as well use brackets, but it doesn't matter anyway. All right. All to the power. They don't matter. All to the power. We know that our B is the learning index. This one. All right. We should get our answer there. Okay. Get our answer there, and we need to do some bit of formatting there, right? Okay, so let's. All right, that's equal sign. First job takes 5 hours, so multiply by the 6 jobs. Okay, to the power B. Okay, and our B determined it there, so obviously that's our the average time. Okay, the average time taken, the average time per unit that is going to be taken when we are producing 6 units. So each of those 6 units is going to take 2.37 hours. All right, and then we are going to have the total time for the 6 jobs. All right, this one is going to take equal sign this average multiplied by 6. Okay, and then we just have to determine the average time taken for 5 jobs. the average time taken for 5 jobs is going to be equal sign time taken to do first job 5 hours multiplied by 5 jobs, okay, to the power b. All right, and we get that much. Okay, so the total for 5 jobs is going to be equal sign this figure multiplied by 5. That's that much. Okay, so we come here and say, because we want the difference, so we're gonna say time for job job for the 60 job, or job number 6, for 60 job, time for the 60 job is going to be equal sign this time minus this time, and we get 1.442687. Okay, that's it, and we come to our answer and determine if we can get that. Yes, the answer is B. Okay, so you just have to be careful when you put the variables in the formula. Okay, it is also necessary to just try to use the copy and paste function to avoid errors. For example, for this second part here, we could have just copied everything here. For example, we had just copied and pasted. All right, for example here, could have just copied the other part for the other part. For example, we copied here. All right, fine. You could see the figures have changed. All right, because of the issue of relative and absolute reference. Okay, the issue of relative and absolute referencing. All right, we didn't want this to change. Okay, this one shouldn't have changed. So in our formula, all right, this formula we could have just put a dollar sign. Okay. Okay, so we need to get rid of the relative referencing, and to do so we just have to put some restriction, because we do not want this cell to change. Okay, this is our reference cell, so we just have to log with the dollar sign. All right, put a dollar sign there, and a dollar sign here. All right, the figures to the same. All right, so when we do our copying, just do this and come here and paste it. All right, so we remove this one because we do not want this one. Okay, all right, so we then have to just at least do some changes there. Right, just put the changes, because right now we want to determine for the 5, so we remove the 6 and put the 5, and you can see that our formula is working properly. Right here again, we edit, we remove the 6, replace it with a 5. Here again, remove the 6. Super. Okay, that's what we should have done. But in the exam, you might discover that because of exam pressure, you would have forgotten about this dollar sign, this and that. You just have to do it manually so that you move, because in the exam, there is no credit for Excel skillmanship. Okay, there is nothing like that, and you end up failing to finish the exam in time. Okay, much of the learning curves theory, we need to go to the other aspect on seasonal variations. I mean, time series and linear regression question. All right, so let us do that question right away. Let me try to locate the question. If you do not have all these questions, ladies and gentlemen, I'll try to just upload them on the link, description link below, so you get them and then you try them and watch the video while you should be having those questions. It's gonna be easier for you, makes your job easier. Okay, this is the question, ladies and gentlemen, I want us to attempt together. All right, so you can just go through the question, pause the video, go through the question on your own. Okay, let me just try to move. No. All right, I hope you are in a position to see what is happening within this question. All right. Okay, and we just want to do part A and B of the question. Okay, for the other one, this one is a bit discursive and theoretical. You guys can read on your own. Okay, so let us just do part A and B of the question. Okay, the Western is a local government organization responsible for waste collection from domestic households. The new management accountant of the Western has decided to introduce some new forecasting techniques to improve the accuracy of the budgeting. The next budget to be produced is for the year 31st December 2010. Okay, waste is collected by the ton, represented by capital letter T. The number of tons collected each year has been rising, and by using time series analysis, the new management accountant has produced the following relationship between the tons collected T and the time period in question, that is Q, where Q is a quarter number. So Q1 represents quarter 1 in 2009, and Q2 represents quarter 2 in 2009, and so on. T is equal to 2000 plus 25Q, that's the model. Each quarter is subject to some seasonal variation, with more waste being collected in the middle quarters of each year. The adjustments required to the underlying trend predicted are, so these are the adjustments, ladies and gentlemen, as you can see, and we have been told, that during the middle parts of the year, the middle quarters, you can see that there is a higher activity, and that's what the examiner is hinting us. You can see that here, the middle quarters, these are the middle quarter 2 and 3, there is a lot of activity. That is why we are having a positive positive figures there, and then on the peripheries the peripheral periods, that is the beginning and the end, we are seeing a decrease in activity. Okay, usually these are the seasonal variations. Okay, these are the seasonal variations, and we know that seasonal variation is usually obtained by the actual results minus the trend. Okay, minus the trend, we get the seasonal variation. Okay, that's the bit of some background. All right, now the question goes on to say, once T is predicted, the new management accountant hopes to use the values to predict the variable operating costs and fixed operating costs that the Western will be subjected to in 2010. To this end, he has provided the following operating cost data for 2009. Volume of waste, total operating cost in 2009, that is fixed plus variable. Okay, inflation on the operating cost is expected to be 5% between 2009 and 2010. The regression formula is shown on the formula sheet. So you're also going to be given this regression formula if you're doing the ACCA Pm paper. All right, so everything is sorted. Let us try to do this question in Excel, because we will be given the spreadsheet and will be required to use those spreadsheets in the exam. All right, so I think we should go straight to the spreadsheet. All right, the information we might actually need first of all is for us to determine the solution to the first part, that is calculate the tons of waste to be expected in the calendar year 2010. That's one thing we have to do. So the knowledge of seasonal variations, trend analysis, is required at this point. Right, so let us get to our spreadsheet to see if we can come up with something sensible. Okay, ladies and gentlemen, I hope you are seeing that we are now in our spreadsheet. Okay, one thing for certain, when you open your spreadsheet, it's going to be blank. Okay, it's going to be blank because you have put nothing there. So you need to input data, but you just have to lead yourself when inputting the data you just have to stand on your principles, on your theory. Okay, we know that given the scenario in the question, we are told that we are planning for the upcoming period, that is year 2010. All right, let us just assume that year 2010 is the coming year. So the figures which we have gathered, the seasonal variation and so forth, has been for the year 2009. Remember, this guy is a new management accountant. He wasn't there last year. He was only here, or he was only in this company this year. So he has only used his experiences of what has been going on using the 2009 figures. All right. So the 2009 year has been covered. We are planning for the upcoming period, that is 2010. All right. So we have got seasonal variations which are in quarters. Okay, and in every year we have got 4 quarters. All right. So we are going to say, ladies and gentlemen, for part A, let us indicate the path so that you can just say A. Okay, so that the examiners will see that that was for A. You can as well write the question number so that they will see. All right. We just have to come up with a decent table. So that is okay, 2010 2010 and quarters. Okay, 2010 quarters. All right. We have got quarter 1, quarter 2, quarter 3, quarter 4. Okay, but remember, we have been given this model T is equal to 2000 plus 25Q. Okay, remember we have been given that in the question. This model, okay, this model is not there for decoration. All right. Oh, what's happening again? Let me try to resave. Ladies and gentlemen, let me try to resave this because this machine sometimes ridiculous. Okay, sorry, I'm sorry. Okay, that's the model we are talking about, and we'll be using this model as part of our estimation. All right, because the question has told us, is requiring us to determine the tons of waste to be expected in the calendar year. So we will be using that model as part of the estimation. So we are required to show maturity a bit. All right, so these are the information, the quarter, the first quarters, those are the quarters, and these are the seasonal variations. Okay, these are the quarters, and these are the seasonal variations. All right, so we come to our spreadsheet and say, okay, model, can you lead us? Fine, the model is there. All right, so one thing, like I said, we have been given the information for the first quarters, second, third, and fourth, which were for 2009, but we are now estimating for 2010. All right, so it means that for the Q value, okay, remember in the model we've got the Q value. Q value represents the number of the quarter we are referring to, okay, the quarter number. All right, so the quarter number here is okay, Q value. All right, we know that we have got 4 quarters in every year. Okay, we have got the first quarter, the second quarter, the third quarter, and the fourth quarter. That one we know. All right, but since in 2009 the fourth quarter has been covered for, obviously the Q value is going to start at number 5. So our first quarter in 2010 is going to be quarter number 5. Forgive me, the laptop is freezing. Okay. Okay, I hope this is not going to be long. Oh man. Okay, that's quarter number 5. All right, and then we are having quarter number 6, quarter number 7, quarter number 8. So you can see that our first quarter in 2010 is going to be quarter number 5. The second quarter is going to be quarter number 6, quarter number 7, quarter number 8. That's how we do it. if we were going to predict for 2011, the first quarter for 2011 was going to be quarter number 9, quarter number 10, quarter number 11, and quarter number 12, and so on. That's how we do this. This is the time series logic. Okay, time series logic. So we input our seasonal variation, variation information. This is just an issue of copying and pasting. Okay, from the information, the seasonal variations, they start from minus 200 plus 250 and so forth. So that's minus 200, 250 plus 250 is the same as just 250, 150, and a negative 100. I hope I picked the figures correctly. Yes, super. Alright, and then we have the expected collection, expected collection of waste. Expected collection of waste. Okay, remember, you can just double click these lines to widen your cells. Okay, like this. All right. Okay, now what figure do you think should appear on the expected collection of waste there? Remember, we are having our model. Okay, the model should lead us, that is T is equal to 2000 plus 25Q. So obviously here our T, the expected collection of waste, should be equal sign 2000, okay, because that's our T, 2000 plus in bracket 25 multiplied by Q, and our Q is this one. Okay, applied by that. All right, plus, remember, plus or minus plus the seasonal variation. Okay, and the seasonal variation this time is minus 200 for this quarter, and just get our value. Okay, and I'm sure, let us try to drag. Sure, the formula has been understood. Okay, and everything has appeared there. We then have to get the total. Okay, the total collection should be equal sign sum. Okay, and get our 8750. All right, you can try to underline your figure so that it looks professional. Okay, just underline it. I'm sure you can also as well bolden the figure so that the marker won't struggle locating it. Okay, that was part A. Ladies and gentlemen, I don't mind, this laptop of mine is troublesome. Okay, we've done for part A, which was requiring us to determine the expected, okay, calculate the tons of what to be expected in the calendar year 2010, and in terms of tonnage that we did the estimation. This is the total waste to be collected or to be expected, that is 8,750 tons. Okay, you've done that. You can go to part B. Part B is all about regression analysis. Okay, part B. Okay, the information we are going to use, ladies and gentlemen, is actually on this part. Okay, once T is predicted, the new management accountant hopes to use the values to predict the variable operating cost and fixed operating cost that the Western will be subjected to in 2010. To this end, he has provided the following operating cost data for 2009. So we are given that. You can see for yourself there that we've got the volume of waste in tons, okay, and the total operating cost in 2009, which is fixed plus variable cost. All right. So you can see that the higher the tonnage collected, the higher the amount of cost. So you can safely determine that the tons are actually our X and these ones are actually our Y values. All right. And remember, in the exam, you would be given the formulas for the regression model, but we know that the regression model is the dependent Y is equal to A. It's a linear equation, A plus Bx. Okay, sorry. Okay, let me try to write the equation somewhere. Okay, Y is equal to A plus Bx. All right, and the question B is saying calculate the variable operating cost and fixed operating cost to be expected in 2010 using the regression analysis on the 2009 data and allowing for inflation as appropriate. So you can see that you are not actually required to determine the complete equation for Y, but required to just determine the A and the B values. Okay, the A and the B values, because A is for the fixed cost, is the y-intercept. The y-intercept is determined, is considered the fixed cost point, while B is the variable cost. All right, the variable cost. So that's all. We are given these formulas in the exam, and we have to use those formulas. So let us try to just test in the formula for this regression model, because we'll be given the formula in the exam, so it's not a big deal. All right, equation, we've got the equation there, which is fantastic. So you can see that since we have indicated that we only need to determine the A value and B value from the equation, you just have to use the formulas given, and those formulas should lead you on what variable you need to calculate. Obviously, for B, we need to determine the summation of xy, summation of x, summation of y, and summation of x squared. So obviously, we have got our x here, our y, our x, y, and then our x squared. Okay, our x squared. Those are the four values we need. Okay, so if we get back to the question, we can see that we need our x is the terms, that is 2.1, 2.5, so 2.1, 2.5, 2.4, 2.3. And then our y value should be 950, 10, 10, 950, 10, 10, 10, 10, and the last figure should be 990. Then summation, xy, for the xy, this one is not found from the question. You need to compute it. So the xy should be equal sign that figure multiplied by that one. Okay, and you just have to drag the values down such that the Excel do everything for you. You then have to determine the value for x squared. Okay, for x squared, that's equal sign this one, okay, to the power 2, and Excel will do the rest for you. Okay, once you've done that, you just have to determine the totals. Okay, the totals simply equal sign sum. Okay, press enter, and then you have to drag everything across, and Excel does it for you. Okay, some bit of formatting might assist so that information is a bit clearer. You just have to justify everything by the center. Okay, we can as well do the underlining so that we won't confuse ourselves. Okay, some underlining is important, so as some boldening. Okay, we've done our part in terms of computing those variables. We then have to slot those figures in the provided formulas or formulae. Okay, so let's start with the B. B is equal to N. Okay, B is equal to N. So let us indicate the value of N. N is equal to, say, N is equal to the value of N. The value of N is the number of rows, as you can see here. Okay, in the question, the number of variable categories. Okay, right. In this case, I've got the category for 2.1 tons, 2.5, 2.4, 2.3. Okay, so we've got 4 set data. Okay, 2.1, 2.5, 2.4, 2.3. So we have got our N is equal to 4. Okay, N is equal to 4, or some time period rather. Okay, period number 1 we've got 2.1, period number 2 2.5 times, period number 3 2.4 times, period number 4 2.3 times. So that's our N is 4. Okay, so we just plot in 4 here. should be 4. All right. But you can see that the formula is a bit complex, so we just have to use some brackets so that our formula is not going to be a challenge. So let us try to have at least open 2 brackets there. Then that's G16 multiplied by the summation of xy. Summation of xy is this one. All right. We close our bracket minus summation. Let us open another bracket. Summation of x, this one, multiplied by summation of y, this one. Close our bracket, close the other one. Okay. All divided by n summation of x. So let us open brackets there. N, that's 4. All right. 4. Okay. Can use this manual 4. Okay. Or you can as well use this one. All right. Multiply by summation of x squared. All right. Summation of x squared, which is this one. All right. Close your bracket minus summation of x squared. Okay, summation of x squared. All right, this is the summation of x. All right, squared. We are squaring this one now. Okay. Okay, let us try to do the formula once again. Saying equal sign. Okay, equal sign. Open bracket, open another one. All right, let us try to input the 4 manually. All right, because n is 4. All right, because in the exam sometimes to put it manually a bit faster. All right, multiply by summation of xy. This is the summation. Okay, close your bracket. Say minus summation of x, this one, multiply by. All right, okay, the summation of x, we can as well, open another bracket, put our x there, multiply by summation of y, which is this one, and we close our bracket. Okay, close our bracket, close another one, then we divide, open again, say 4 multiplied by 4 multiplied by the summation of x squared. Okay, summation of x squared. This is the summation of x squared. Close our bracket and we say minus, open bracket, summation of x squared. We get 0.16. Okay, that's fine. We are sure now that we are right on track. We then have to determine the value for a. Okay, and from the formula we have got equal sign, open bracket, summation of y, all right, over 4 minus b. This is our b. Okay, minus b multiplied by b multiplied by summation of x over 4. Okay, and here you can as well put a bracket here that your formula is going to be neat and super. Okay, get your 618. All right. Okay. Okay. But from the question, I'm sure we agree that we didn't input these values according to thousand. Remember, they are in thousand, the monetary values there. So we need to adjust our figures to reflect that. Okay, so B would actually be, okay, can as well say, all right, or we can just come here and say this figure multiplied by 1,000, we get our 160. Similarly, this one, A, should be that figure multiplied by 1,000. Okay. So, what does this mean to us? Let us get back to the question again. Okay, the question once again is saying calculate the variable cost, operating cost and fixed operating cost to be expected in 2010 using regression analysis on the data, on the 2009 data, and allowing for inflation. So we need to allow for inflation. Okay, we need to allow for inflation. We have already determined the variable cost per unit, okay, but without incorporating the inflation figures. All right, so we need to get back to Excel. Okay, remember B is the variable cost. Okay, the variable cost per unit. All right, so we need to allow, okay, for inflation, and we are told that inflation is 5% from the question. Inflation is expected to be 5% between 2009 and 2010. So we're going to say equal sign this figure multiplied by 1.05, and we get 168. We adjust as well the A figure, which is this one, multiplied by 1.05, and we get that one. So we just have to come here and say therefore the variable cost per unit or per ton, okay, per ton is $168, and the fixed cost in total is $648,900 for 2010. Once you do that, you're home and dry, you have attended your part B, you should be happy and start to congratulate yourself. Okay, ladies and gentlemen, I hope you have been assisted with this video. If you need more coaching for your future studies or for this ACCA Pm exam, if you are preparing for your forthcoming examination, please do not hesitate to contact me on the numbers, email addresses supplied on this video or on the link below, where you're gonna go to my website, that is Transcal Consulting, www.transcalconsulting.co.zw. Okay, Transcal Consulting Services is there for you, ladies and gentlemen. We coach you at whatever ACCA module you would be studying. Okay, if you are not the one who is studying ACCA, you can as well share this video with your friends who are studying this global qualification so that they can benefit as well. I will be there. As you can see, we are energetic. We are ready to take you through this ACCA journey with easy. Okay, one more thing. For you to benefit a lot, you need just to be a student so that you will also have the exam structured notes. All right, we also offer continuous assessment, that is some assignments, exercises, practical simulations, so that when you reach the exam point, you would be saturated, you would be having everything you need to pass these exams. Okay, so ladies and gentlemen, I hope you have been helped. Don't forget to subscribe, to share, to like, or to comment on the comment section below. Okay, on the comment section below, so that I know if I'm doing the right thing or not. All right, until next time, ladies and gentlemen, may the good Lord continue to bless you, to make you a wonderful people. All right, to shine upon you, so that your future is gonna be full of grace, full of light, full of prosperity. Thank you. I'm signing out.